Welcome to EDU World Space.
In this problem, we will let m be the mass of each ball, since all three balls are identical. We will then use the conservation of linear momentum. So the conservation of momentum tells us that the momentum after the collision is ma va, the momentum of ball A, plus, or instead of ma, we'll just write m, since all the masses are identical. So mva plus mvb plus mvc is equal to the initial momenta for each ball. So mva naught plus mvb naught plus mvc naught. So those are the momenta of each ball before and after the collision. If we then divide both sides by m, since m is common throughout, and we apply our numerical data, we get, so the final velocity va is 0. So mva is 0 plus 6 feet per second in the I direction plus vby, which is unknown, in the j direction plus vc x times unit vector I plus vc y times unit vector j is equal to 8 feet per second times unit vector I. The other two have initial velocity 0, so b and c are initially at rest. So if we break this equation into its components, its x and y components, we get two scalar equations from the one vector equation. So 6 plus the x component of vc is equal to 8. Resolving the y components, we get that the y component of vb plus the y component of vc is equal to 0. We'll call this equation 1. So the y component of vb is minus the y component of vc. And next we'll use the conservation of angular momentum about O. So we've used the conservation of linear momentum, now we'll use the conservation of angular momentum about the origin. And the conservation of angular momentum says that the sum of the position vectors for each of the particles crossed with their momenta, mv, must be the sum of the position vectors crossed with the initial momenta of the particles mv naught. So the angular momentum before about point O must be the same as the angular momentum after. So remember, Ra is equal to 0, Rb is equal to 0, and Rc is equal to 1.5 feet times cos 45 degrees I plus sine 45 degrees j. And so what this tells us is that Our angular momentum equation gives us 1.5 times the cos of 45 degrees in the I direction plus sine 45 degrees in the j direction cross with mvc, the final x component of the momentum of c, plus the mass times the final velocity of c, its y component in the j direction, is equal to 0. So that's the conservation of momentum. And since the cross product is 0, the two vectors are parallel. So we can see that VC, the y component of VC, is equal to the x component of VC tan 45 degrees. And so this is equal to 2, since we know the x component, times tan 45 degrees. And so the y component of VC and 2 tan 45 degrees equates to 2 feet per second. And then we can then calculate VC or VBY. So from 1, we get the y component of VB to be minus 2 feet per second. So we calculated VBY to be minus 2 feet per second, and VC 2 feet per second I plus 2 feet per second J.